Okay. A continuous random variable is a chance process, or the variable, the outcome of a chance process, of a number with infinite possibilities. Normally when we're talking about this, we're talking about height, time, speed. All of those would be continuous because you can get any number that you want. So in problem number 1, we're talking about continuous. So this spinner we're talking about goes from 0 to 15, where you can stop anywhere from 0 to 15. And we've done problems like this. And the height is going to be 1/15 because the area has to be equal to 1. So what is the probability that x is less than 10? Well, here's 10. All of this stuff is less than 10. So the base is 10. 10 times 1/15 turns out to be 0.667. What is the probability that 3 is less than x is less than or equal to 10? By the way, this or equals doesn't mean anything. If it was there or if it wasn't there, we'd get the same answer, so let's not worry about that. So if I'm doing part B and it stops at 3, I need to only have the area shaded in between 3 and 10, which has a base of 7. So 7 times 1/15 turns out to equal, alright, for letter C, it says, and I'm going to rewrite this, probability that x is bigger than 5 and x is bigger than 10. So if you want something that is bigger than 5 and bigger than 10, here's 5, bigger than 5. Here's 10, bigger than 10. And if we're doing an AND problem, that must mean the green and the black have to be shaded. So that section is 5. So I got 5 times 1/15, which is 0.333. In letter D, they changed it to probability x is bigger than 5 or x is bigger than 10, which means that we are talking about anything that's shaded, which means we're really talking about that section, which is 10 times 1/15, which is 0.667. For letter E, probability that x is equal to 10, always when we have a continuous random variable and we get just one number, the answer is going to be equal to 0. For example number 2, if you wanted to, you could pause now and try it yourself because it's about the exact same. This time we're going from 11 to 20, which means the height is going to be 1/9 because the distance between 11 and 20 is 9. So let's erase that. And the area would then be 1 again. What is the probability that x is bigger than 18? It would be that section, which is 2. Base of 2 times 1/9 turns out to be 0.222. Probability that x is less than 13. Oops. Let's rewrite that. 13 is less than x is less than or equal to 20. Once again, that or equal doesn't matter. So here's 13. So in between 13 and 20 is all of the orange, which is 7 as the base from 13 to 20, times 1/9 turns out to be 0.778. What is the probability that x is bigger than 21? Well, since 21 is over here and it's going that way, the answer is 0, because nothing in our graph would have been bigger than 21. And finally, the probability that x is bigger than 13 or x is bigger than 17. So let me go back up to this graph. Here's 13. Here's 17. Bigger than 13 is all this. Bigger than 17 is just this. And we're just talking about what is shaded. So all of this is shaded with a base of 7 and a height of 1/9, which is 0.778 again. For example number 3, we did uniform distribution, so let's draw one that doesn't have and one that is a continuous that we're about to do more problems with is a normal distribution. Anything that's skewed right or left, this one is skewed left, could also be a continuous as long as in both of these problems the area is equal to 1. Alright, speaking of the normal distribution, we're going to go back to this. Suppose that 12% of all undergraduates say that they would turn in 2 students that they caught cheating. If they surveyed 400 students, and realized that there would be a mean of 0.12 and a standard deviation of 0.016. What is the probability of the sample being, that should say, more than 2% away from our expected result? Well, that means that it would have to be above 14%, or it needs to be below 10%, and these two things, these two shading regions would be equal because of symmetry. So I'm going to find the z-score for 10%. I'm not going to worry about the 14% because I could get very well. So that gives me a z-score of negative 1.25. For those of you who have your z-table still and like to use your z-table, you look this up, and whatever answer you're going to multiply by 2. For those of you who are using the calculator, we're going to use our normal CDF from negative 9999 to negative 1.25 with a mean of 0 and a standard deviation of 1. And whatever answer we get there, we're going to multiply by 2 because we have 2 different regions. So when you look it up in the table, you should wind up with 0.1151, which is also what you get on the calculator. And then you multiply by 2, and you get 0.2301. So that means 23% of the time you're going to get an answer that is more than 2% away from the correct answer. Let's try letter B. So we want a percentage higher than 11%. So here's 0.012. Here is 0.016. Actually, this is just 0.12. And we want bigger than 11%, which is everything over here. So first we're going to find the z-score. 0.11 minus 0.12 divided by 0.016. And we get negative 0.625. Which I'm going to round to be negative 0.63. So that everyone gets. So for those of you using your table, when you look up negative 0.063, you get we get 0.2643, and when we subtract that from 1, because we're looking for greater than, we get the answer of 0.7357. For those of you who use the normal CDF, we're doing from not from negative 9999, from 0.63 to 9999, because we're going up with a mean of 0 and a standard deviation of 1, which means we get 0.7357 again. In the last problem, we're looking for the middle 95%, which, if we remember from our other problems, that is 2 standard deviations. So I'm going to take 0.12 and I'm going to subtract the standard deviation times 2, because we're doing 2 standard deviations. And I'm going to do the same thing with the plus. So we got between, so that's 8.8% to 0.152. Alright, hopefully you have your normal tables. If not, I put a link in your email to link to a table that you can look to online for now. If you have any questions, please email me.